Let's practice finding the volume of some rectangular prisms together. Jumping right into it, for number one, you can see all the little unit cubes that are filling up this right rectangular prism. The length here, we can go ahead and say, is going to be 2.5 centimeters. So I'm going to put that in as 2.5. The width here is going to be also 2.5. So far the base is going to be a square. And if you take a look at the height here, well, the height is also 2.5. So not only is this a right rectangular prism, but it's also a cube. Right, so let's go ahead and see if we can go ahead and find the area of the base. So the area of the base, we typically call that capital B. So let's go ahead and say we have the L is going to be 2.5. We know that the W, or the width here, is going to be 2.5. And we know that the H is going to be 2.5. Now, for the area of the base, that's going to be capital B. That's going to be equal to the length multiplied by the width. Now, in this particular case, we know that is going to be 2.5 for the length multiplied by the 2.5 for the width. Now, if you go ahead and multiply that out, we should get 6.25. That would be the area of the base here. So let's go ahead and write that in as 6.25. Okay. And then how do you find the volume of a right rectangular prism? Well, the formula is capital V is equal to whatever the area of the base is multiplied by the height. We already know the area of the base here is going to be 6.25. So it's going to be 6.25 multiplied by whatever the height is, which is also that 2.5 because it was a cube. And so if we go ahead and take 6.25 and multiply that by 2.5, we should end up with 15 and 625 thousandths. This right here would be the volume of this right rectangular prism. So I'm going to go ahead and write as 15.625. So I'm going to write that as 15 and 625 thousandths. That's cubic centimeters. That would be the volume of this prism. All right, let's check out another one here. This one, we're going to deal with some fractions. For the length here, it's up to you which one you want to say between the 10 and the 3.5. Doesn't really matter, but here, I'm going to say the length is going to be 10. For the width, I'm going to say that's going to be 3.5. And then for the height here, the height looks like it's going to be 1.5. So let's go to put 1.5. Okay, so let's go ahead and write what we have down here. We know the length here is going to be 10. We know the width is going to be 3.5. And then we know the height is 1.5. Okay, cool. So the area of the base, that's going to be capital B. That's going to be just the length times the width. In this case, this is going to be 10 multiplied by this 3.5. All right, so let's go ahead and see if we can do that. As an improper fraction, this is 10 over 1 multiplied by 7 over 2. We can go ahead and cross cancel the 10 and the 2. Go ahead and just simplify that a little bit. And so this ends up being 35 over 1, or just 35. So that's the area of the base, or the bottom here. All right. Now what's our formula for the volume of a right rectangular prism? It's capital V is equal to capital B, or the area of the base, multiplied by the height. Now the area of that base is going to be 35. And how tall is this shape? Well, we said it was going to be 1.5. So let's multiply that by 1.5. So this is going to be, as an improper, 35 over 1 multiplied by 3 over 2. I don't think we can really cross cancel anything here, but I think 35 times 3 is going to be 105. 105 over 2. That's not going to go in evenly, right? So 105 divided by 2, though, is going to end up being 52 and 1/2. Okay, so that's going to be the volume of this rectangular prism, 52 and a half here. So that's going to be our volume, 52 and 1/2. And what do we have for our units? We have cubic inches. So that would be our volume. All right, cool. Let's check out another one here. For number 3, we have another right rectangular prism. We have some fractions again here. For the length, let's go ahead and say the length here is going to be 6 yards. Let's go ahead and put 6 in. For the width, let's say it's 1 2/3. And then for the height here, we can say the height is going to be 3 1/3. I'm going to put it in 3 1/3. So let's go ahead and just label those things down. The length is 6. The width is 1 2/3. And then the height we said was 3 1/3. And let's start next going ahead and finding out the area of the base, which is going to be the length times the width. So that's going to be 6 multiplied by 1 2/3. As improper fractions, this is going to be 6 over 1 multiplied by 5 over 3. You can go ahead and multiply then simplify, or you can see that you can divide these both by 3. That becomes a 1 and a 2. So the area of the bottom of this prism is just going to be 10 square yards. Now to find the volume, we can go ahead and put the area of the base here as 10 square yards. The volume is going to be the area of the base multiplied by the height. The area of the base here we said is 10, the height is 3 1/3. So going ahead and doing this as improper fractions, that's 10 over 1 times 10 over 3. So we can't really simplify it all here, but this is going to be 100 over 3. And if you go ahead and turn this into a mixed number, this is going to be 33 1/3. So that's going to be the volume of this prism. What are our units? The units are going to be cubic yards. So we'd have 33 1/3 of these little 1 by 1 by 1 yard cubes. All right, that would be the volume. All right, here is a fourth example. For this one, very similar. We got some fractions again here. So for our length, let's go ahead and say that's going to be 4. For the width here, let's go ahead and say that's 1 3/4. Okay, and then for the height is going to be 2 1/2. So let's go ahead and put all that information in here. Okay, so let's go ahead and say we have the length is 4, the width is going to be 1 3/4. And then the height here is going to be 2 1/2. All right, cool. So find the area of the base, same thing as the last few problems. It's going to be the length multiplied by the width. In this case, our length is going to be 4 and our width is 1 3/4. As improper fractions, we can say this is 4 over 1 multiplied by 7 over 4. And what's nice is here is we can go ahead and cross out these 4 over 4s because they're just equal to 1. And so this simplifies down to just being 7. So that's the area of the base here. Okay. Now to find the volume, that's just going to be the area of the base multiplied by the height, as we've been doing. The area of the base we said was 7, and the height here is going to be 2 1/2. So as an improper fraction, 7 is 7 over 1. 2 1/2 is the same thing as 5 over 2. We can't really simplify anything here, so just multiplying the numerators and denominators, we're going to get 35 over 2, which is 17 1/2 as a mixed number. So that would be the volume of this prism. It's going to be 17 1/2 what? Little 1 by 1 by 1 inch cubes. So we can fit 17 1/2 of those inside there. All right, so let's try some applications now. In 5 and 6, we have a couple different applications to look at, or just extensions to kind of think about. In number 5, Samara uses a pan for baking brownies. There's a 3/4 inch space at the top of the pan when her brownies are done baking. What is the volume of the brownies? And I forgot a little A in here, so sorry about that. That's going to be Samara made. So let's see. Okay, so the whole pan goes up to 2 1/4, but the brownies don't make it all the way up. The brownies kind of stop part of the way through here. So I'm going to go ahead and just kind of show what that looks like. So if we're saying that 2 1/4 is the entire thing here, the brownies are actually going to stop right around here maybe. And there's some empty space between the tops of the brownies and the tops of the pan here, right? So hopefully this kind of makes sense. Typically brownies don't go to the very tippy top here, but we know that this space over here, this little empty space, is going to be 3/4 of an inch. So the brownies are going up to here basically, and they stop. So how tall are the brownies? Well, we already know the length of the brownies and we already know the width of the brownies. It looks like there's a square pan here, but how tall are the brownies going to be? Well, the height of the brownies are actually going to be 2 1/4, the whole height, minus all that empty space for the tops of the brownies there, right? The empty space there. So if we go ahead and do that, this as an improper fraction would be 9 over 4 minus 3 over 4. So 9 minus 3, it's nice we already have common denominators. This is going to be 6 over 4, which is the same thing as 3 over 2 if you simplify. And so we have basically the height of the brownies is 1.5 inches, right? That's actually the height of the brownies. The height is 1.5 inches tall. So if we're going to find the volume of her brownies, that's going to be the area of the base multiplied by the height. Now to find the area of the base, let's go ahead and do that on the side here. The area of the base is going to be the length multiplied by the width. The length of the brownies are going to be 8.5, and the width is also going to be 8.5. So as let's see, as improper fractions, this is going to be 17 over 2 multiplied by 17 over 2. Now what's 17 times 17? Feel free to pause and go ahead and multiply that out. I think that's going to be 289, and that's going to be over 4, because 2 times 2 is 4. Now if you take that 289 and you divide it by 4 to get a mixed number, it's going to go in 72 times with 1 left over. So it's going to be 72 1/4. So this right here is going to be the area of the base. So we have 72 1/4. This is the area of the bottom of this pan. We're going to multiply that by the height of the brownies, which, again, don't use this height here. We're going to use the height of the brownies where they actually go to, which is going to be 1.5. Okay, so 72 1/4. What is this as an improper? We'll just go backwards here and take this 289 over 4. And then if we go ahead and write this 1.5 as an improper fraction, that's going to be 3 over 2. Okay, now let's go ahead and just multiply the numerators together and the denominators. For the denominators, 2 times 4 is going to be 8. For the numerator, though, we have 289 multiplied by 3, and that's going to be 867. Okay, now how many times is this going to go in? Well, go ahead and do the long division there. It's definitely going to go in over 100 times, right? So if you take that and divide by 8, again, feel free to go ahead and pause and go ahead and take care of that long division. It's going to go in 108 times, and I think the remainder is going to be 3. So 108 3/8 here. So it says, what are the volumes of the brownie, or what is the volume of the brownies in the pan? The volume is going to be 108 3/8, and then we have cubic inches. If we were to cut up all those brownies into little 1 by 1 by 1 cubes, you could fit 108 3/8 of those cubes inside of this brownie pan. Okay, all right, cool. Let's go ahead and check out number 6. In number 6, it says, find the volumes of 2 rectangular prisms described in the table. If you divide each dimension of the larger prism by 2, how does a new volume compare to its original volume? Well, if you take a look at this one up top, this is going to be the larger one, right? If you look at all these dimensions that we have here, all the dimensions are bigger. And then if you look at the one on the bottom, this is the dimensions of the smaller prisms, right? So these are the ones that they are talking about. It says find the volumes of each of these, and it's asking kind of like what's the relationship between the two of them. So if you divide all the dimensions of the top prism by 2, how do the volumes compare? So notice how the length was cut in half, the width was cut in half, and the height was also cut in half. So they're wondering what could we expect would happen to the volume if you cut each of the dimensions in half. Okay, so let's go ahead and find the volume of the larger one. I'm going to put a little L for larger. Volume is going to be the area of the base multiplied by the height. We know that the area of the base is going to be the length times the width, right? So let's go ahead and substitute these values in here. This is going to be 5, which I'm going to write as an improper fraction right away. That's 5 over 1, multiplied by 4.5, so that's going to be 9 over 2, and it's going to multiply by 6, which is going to be 6 over 1. Okay, now if you want to simplify first, you can. So the 2 and 6, you can divide them both by 2, and so we're going to end up with a 3 here. And then if we go ahead and look, all the denominator values are 1, so that's kind of nice. So we're not going to have a fraction answer. And then if we do 5 times 9, I know that's 45. And if you do 45 times 3, I believe that's going to be 135. So that's going to be the volume of the larger one. It's going to be 135 cubic inches. All right, that's the volume of the larger prism, 135 cubic inches. Okay, what about the volume of the smaller one? Well, the volume of the smaller prism is also going to use the same formula. So we can go ahead and write this down here. And then the length is going to be 2.5, which is 5 over 2, times 2.25 is the same thing as 9 over 4. And then 3 as a fraction is just 3 over 1. I don't really see anything we can cancel out here, but if you multiply the denominators, this 2, 4, and 1, 2 times 4 is 8. 8 times 1 is still going to be 8. We're going to keep that on the bottom. And then for the numerator, well, we really just have the same 3 numbers that we had earlier, 5, 9, 3. So don't do that work again. It's just going to be 135. Okay, so this is the volume as an improper fraction, but what's the volume as a mixed number? Well, we can just do 135 and divide that by 8. So if you go ahead and do that, 135 divided by 8, it's going to go in 16 times with 7 left over. So it's going to be 16 and 7/8, and that's going to be cubic inches. So 16 and 7/8 cubic inches. Okay, so we found the volumes of both of these prisms, but the question asks, how does the new volume compare to the original volume? Now, keep in mind that from here to here, we divided by 2, right? There was half. From here to here is also divided by 2. And when we went from here to here, we also divided by 2. So I guess the question is did we just divide by 2? I think that's kind of a common thing that a lot of people are going to think. But if you cut 135 in half, it's definitely not 16 and 7/8. Now, if you go ahead and look here at these two values, here was the original volume, and here is the new volume. If you just look at their improper fraction versions, this is really just 135, right? Anything over 1 stays the same. But this is an eighth of it, or it's cutting it into 8 pieces. So, you can kind of see here that it is 8 times smaller than it used to be. So what's the relationship here? Well, if you take this 2 and you multiply it by these 2's, 2 times 2 is 4, and 4 times 2 is 8. If you were to go ahead and take each dimension and cut them all in half, you got to make sure you can see that the relationship for the volume would be not just half as big, but it's going to be 8 times smaller than it used to be. So we can go ahead and say here that the new smaller prism, where all the dimensions were cut in half, has a volume that is 8 times smaller than the original one. Basically, dividing the 3 dimensions each by 2 results in the total volume getting halved 3 times. So if you take half of a half of a half, you end up with an eighth. All right, so there you have 6 different practice problems on going ahead and practicing finding the volume of right rectangular prisms. Hopefully the first 4 felt a little bit more comfortable as you got the hang of using the formulas. And then 5 and 6 were extending just a little bit and then trying to apply the understanding of volume to a couple different scenarios. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or a friend who might also find it helpful. And as always, keep up the great work that you're already doing.